This is the URE Podcast, released October 15th, 2017. Episode 363. An interview with Alvaro and Jen from the Reverse Engineering Podcast. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Alvaro Prieto from the Unnamed Reverse Engineering Podcast.
And I'm Jen, also from the Unnamed Reverse Engineering Podcast.
Crossover podcast. Welcome, guys. How you doing?
Good.
Okay.
All right. Well, the name. We got to talk about the name to start with.
What name?
Yeah, exactly.
Names are hard.
How long's this show been on the air? I guess we've mentioned at one point, but...
So we have 4 episodes, but they're very erratic. We started the first one maybe in August or early August?
No, July.
Oh, July. Yeah.
I think it was July 18th.
Yeah, so we record, then we pretend to edit for a while, and eventually put it up. Okay. We're still learning.
Okay. Well, consistency. That's what we always say. That's the only reason the Amp Hour is still around. He says after not posting an episode last week.
Yeah.
So, well, anyways, welcome. I have taken a listen to the show. It's some interesting stuff. And so why reverse engineering? I mean, what about that, piqued your interest in the first place?
I mean, I've always liked taking stuff apart, but what really got me into it was Micah Scott, when she did her coaster melt videos. I don't know if you've seen them.
Oh, yeah. Yep.
That's the
CD, this was CDs,
yeah,
right?
I think it was a Blu-ray player. She was... Yeah. Reverse engineering so she could control the laser and do all sorts of stuff. When I saw that, I thought it was the coolest thing, and it kind of got me much more interested in taking a little more in-depth look at that on my own, and that's when I did little quadcopters and that kind of thing. That's how it started.
Cool. What about you, Jen?
Well, I didn't get into quadcopters, but we had been talking for a while in the background about doing reverse engineering and that there just wasn't an easy way for people to learn more about it, particularly because we wanted to learn more about it. We know the best way for us to do that is by interviewing a bunch of people who know what the heck they're doing. Or maybe they don't know what they're doing, but they're really good at pretending. So we just kept talking about it for the last year and a half, and then finally... I think sometime over the summer, we just had hit our point where we're like, it's time for us to go do this.
You got to hit record at some point, right?
Yep.
Yeah.
That's great. Well, and Jen had written to me, I had mentioned on the show a couple weeks ago, I was going through past guests, and I was trying to say, I was saying that we really haven't had many consumer electronics people on the show before. And I think that was pretty well, I actually haven't reviewed since, but I think that was pretty well proven. But obviously I know a lot of people out in the Bay Area. You're both out in the Bay Area, and there's a lot of consumer stuff going on out there. So can you give us kind of a rundown of your backgrounds and what you're allowed to talk about for the the consumer level electronic stuff? So
mostly I've been a firmware engineer on a lot of different consumer products, and they kind of run the gamut between startups and large companies. So I've worked for Movea when they were still doing mice and keyboards. A bunch of XDSL modems back in the 90s and early 2000s. I even worked on the URE set-top box and
cool.
the Amazon Fire Phone, which is probably the product that people least like. And also the Fire TV. Yeah. There's also the Fire TV set-top box, including the remote. So I worked on both halves of that. And then I've done... Nice. The last 4 companies I've worked on have pretty much all been wearables. So that's been BIA Sport, who was a Kickstarter delivering stuff for triathletes, and then a couple of different failed health-centric ones, and then finally something I've been working on, some sort of denim-based product lately that has been around now, I guess, for about 2 weeks now.
Cool. Okay. What about you, Alvaro?
So I started, I guess in college, I did the co-op, and it was a train track control system company, and I was doing firmware.
But a consumer one, huh?
Well,
Sorry,
our consumers.
I'm just imagining someone being like I really need this for my backyard.
Well, for my back train yard, perhaps.
Yeah, right.
But that's how I got started in firmware in like industry, I guess. And then when I graduated, I went straight to TI, and I was doing firmware there. And then I got recruited by Apple, and I worked there for like 3 and a bit years. Then I switched over to satellites, which is also not kind of consumer, but kind of fun at Planet. It used to be Planet Labs, now it's Planet. And then I took 5 months off, enjoyed my life, and now I'm at a medical device company.
Very cool. Well, that's a lot of devices too. I mean, I guess that kind of leads to the first question is, like, what is the pace? I mean, so I believe that's what me and Dave were talking about, is that, you know, just the development cycles and the pace and stuff like that, and really the stress. So, like, could you give us a comparison of, like, so Alvaro, you've done the industrial stuff. Jen, have you done industrial as well?
Yeah, actually, the other thing for the last episode that you guys released, you guys were talking about PC 104. I worked for another PC 104 single board computer company, so I was giggling a lot about you guys talking about system on chip.
That's always people's reaction, is they're giggling. I don't know if you guys saw Paul, one of the DIY battery Powerwall things. He did a reaction video. He was like laughing and just scolding us. It was
a reaction video to the amp hour?
Yeah, it was fun actually.
Oh, wow.
I rather enjoyed it. Paul's out of New Zealand. It was great. Yeah. But yeah, so okay, so you both have industrial experience as well. So give us like a compare and contrast. What's the difference in the feel and the working situation like?
Well, I guess at least for me, I have like a handful of customers on the industrial side. I just need to deliver to them whatever they are going to do for their final application. Like, may actually be consumer facing, but for the most part, it isn't. It's just dealing kind of more one-on-one. They're a little bit more tolerant of what they want, and they're just buying in bigger volumes. Whereas consumers, it's death by 1,000 complaints.
Okay.
And it's just a lot more visible when you fail.
Yeah, my consumer electronics is a little more special, I guess, because Apple, it's a little different.
Who's this Apple? Who's this Apple I've heard of?
Yeah, yes, it's a small company in the Bay Area. But yeah, they don't follow the usual rules of a small consumer electronics company. And I was more in the R&D side of things, so I dealt more with prototypes and that kind of thing, and internal products as well.
Okay.
But I worked with people from all over.
So I mean, but either way, I'm sure that you've talked to or saw the design cycle stuff, and people, you're talking to people that are outside of your groups, perhaps. Is it a 3-month design cycle? Is it a 6-month design cycle? Is it noticeably different from working in an industrial company, or like what is that like?
So I mean, from what I've noticed, industrial, the deadlines are a little more flexible. With consumer electronics, you got to hit. I mean, cell phones are yearly cycles nowadays, right?
Sure.
But a lot of the industrial stuff, it'll just get pushed back. And it's like, that's just what happens, and people just gonna get their whatever device later. It seems to be the case, at least in my experience.
There's a little bit of luxury that you have when you're doing when you're launching a product line, that you have a little bit more time, because once you launch that first product, the iterative ones happen on that yearly cycle, which means you're locked in. You're a lot less likely to take on new risky features. Usually those are already mapped out as you're closing up the launch of the previous product. So once you're on the cycle, there's just it's just you just keep running, and there's just not as much innovation that's happening.
Got it. Okay. Yeah. So that makes a lot of sense. That it's especially because the overall. So like I think about the industrial stuff, the stuff I used to work on. I remember I was, I guess both companies that I worked at in the industrial space, I was refreshing product lines that were 30 years old, right? I mean, like, so, but phones obviously don't do that. At a certain point, they just scrap the whole thing and not start over, but, start from a new code base, a new hardware basis, because the hardware is changing so much too.
Yeah, but I guess the urgency isn't there. If it's a 30-year-old product, if it's made it so far, you don't need it just...
Oh, no, there's urgency. But I thought there was urgency, especially if you have end of life, going back to single board computers.
Okay. Yeah.
Once that thing goes end of life, there's panic.
Right. Well, and that's usually the problem too, is that the product line refresh usually people are like, oh, we'll be fine. They're like, oh crap, we can't buy the processor anymore because it's a 68 HC 08 or whatever it is.
Something. Yeah.
Yeah, whatever it is. Yeah. I
was
was
that horrible design. Stuff. I hate that one.
I just did the stuff around it, but yeah, I mean, either way, they never actually refresh it in time, and it's the scramble, I suppose, is like you said, Jen. It's just that, hurry up right now. We got to keep making money, this thing, or else you're just going to cancel the whole thing. So, yeah, that's interesting. The other thing about the timeline stuff too. It's interesting with the numbers, right? So if you have 10,000 paying customers paying $5,000 of each, right, or 10 million customers paying $5 each, right? It could be this. I don't know if that math works out, but whatever. If it's it's a difference in the overall money might be the same, but the per unit cost could be radically different, right? So if you have to hit that mark, or else you won't be able to sell it for $5,000 or whatever.
You're not going to achieve your economies of scale.
Yeah.
You at some point as your volume goes up, you want to be able to save some amount of money. You should be able to negotiate better prices on all your parts and all the packaging and distribution channels when you get there. When you get to millions of units.
Yeah, that's the nice thing about industrial. You don't have to worry about a lot of that stuff, right? You can use a slightly more expensive part. You don't have to start a penny pinch. If you're only going to sell 5,000 of these, it's not a huge deal.
Mm-hmm. Yeah,
I think it depends. But what I remember it being a big deal when we did packaging for some of these single board computers, like, ooh, look, a clamshell for us to ship in. It was a big deal that we went that far.
Right. Yeah, it's got that extra touch and cost and whatever, right?
There was a whole article about don't try to do what Apple does. I don't know if you remember it, how just getting white plastic that's actually white, unless you're doing it at some ridiculous scale, is just not worth it. Or they had, I'll try to find it and we can put
it. Was that Ben Einstein maybe, like the Bolt Ball blog?
I don't remember.
I know he writes about Apple a lot.
Let's see if I can find it.
Yeah.
So there's the quality control even around those consumer parts.
Mm-hmm.
What I was going to comment upon was, so the way that Apple goes about, and I can't speak specifically to what happens internally to Apple, but talking with some of their other vendors for manufacturing stuff to get similar outcomes for different colors of devices, let's say. You end up with just a lot of industrial samples. You have those golden samples that are sitting at the end of each manufacturing line to make sure that each batch that comes out is either acceptable or not before you start putting them on the backs of your product that's going out the door.
Yeah, it is the Bolt one.
Yeah, that's great. That's a good link to have there.
Yeah, no, you can't manufacture that like Apple does.
No, they go through a lot of pains to get that done.
Yeah.
Yeah, right. So both of you are in the firmware side, though. So what does that end up playing out like? So you're talking about obviously we're talking about hardware here, but what does that end up playing out with in terms of the efficiencies that you were talking about? So you said the economies of scale. Obviously, you get better per piece pricing because you're buying so many and stuff like that. But I also assume that you need to really, really cut down the code base to try and get that cheaper part in there, or less memory or whatever. So how does that end up impacting the firmware side of things?
Alvaro, did you want to talk about this? Because otherwise I'll rant for a good
go
hour.
For it.
Okay.
All right, here we go. It's the Jen show.
We'll cut you off.
I don't know if I don't know if I'm going to quite get it to an hour.
Okay.
So what I'm noticing, at least in consumers, like from the get-go, your hardware team is already picking the smallest part possible, and very rarely is there, unless they're particularly sensitive, they're not necessarily going, hey, do you really need this really big part? Otherwise, we're just going to pick the one with 128 on there, and that'll be that. There's just generally not that much back and forth, at least that I've noticed on the last 6 or 7 companies I've worked at. In addition to that, with the economies of scale, I would say, at least from my perspective, I don't know about you, Alvaro, but I often end up doing the manufacturing for a lot of my products also. And that all started because I used to be the super junior.
What do you mean by the manufacturing? Like the manufacturing tests?
The manufacturing tests, the writing all the scripts that drive the test stations, designing the assembly test stations, knowing what the timing was, figuring out how to get all that information, logging all the information, get up to backend so operations can then look to see where the big fallouts are. So at one point I was driving all of that in a couple different companies that I've worked at, just because when I was earlier in my career, if you were the low person on the totem pole, you got to do all that work. And so now it just continues. Now I just get to do it in China.
Right. Now they're like, oh, Jen knows how to do that.
That's dangerous.
Right. Yeah. So when I worked for BS Sport, I was the director of engineering. And even though I was doing some firmware work and some algorithms work, there was no mechanical engineer. So I became the mechanical engineer for the company, in addition to spending a lot of time in China crying and looking at the electronics markets and not being paid.
That's what happened to me at Planet. I was originally going to be doing firmware for manufacturing. Oh, close. Not at the office. I originally was supposed to be writing firmware because there was a firmware team, but I was in the manufacturing team that I was going to do firmware specifically for testing, right? But I ended up just writing test scripts because there was not enough time to, for me to just not work on the line and get the special firmware up and running. And after 6 months, I am now a test engineer. And, I was doing R&D, just firmware and stuff at Apple. I went to work on satellites. I'm supposed to be writing firmware, and then I'm afraid what's going to happen, the same as Jen, that like, oh, you're good at testing stuff, and that's going to be the rest of your life. So
right. They love to have those people, but they don't pay them that much more, right?
Well, exactly. It's mostly, I don't mind doing that, but that's not what I wanted to be doing at the time. That's not what I was told I was going to be doing.
Right.
Because it's fun to automate stuff and do all that stuff. But I want to write C. It's cool to learn Python and do all that stuff, but I don't want to become the testing guy.
Right.
But you know what? You're in a unique position, Alvaro. You know hardware, and even with firmware engineers, a lot of them don't know hardware. They don't understand how a product can break when it's being assembled, because you're no longer testing the design, you're testing the assembly of that particular unit.
Yeah, exactly. So your firmware might be fine, and you have a hardware problem, or your hardware's fine, you have a firmware problem. I used to be that person that can go in there and figure out which, and then fix it.
Yeah, the fixer. Yeah, exactly. The fixer is necessary, but it's the hours and the
I wish it was a rotation program or something, because there's these things that nobody likes to do, but they have to be done. Yep. And imagine that each team does it for 1 month or something, and then nobody suffers too much.
Right. Well, some of this sounds like it's also big company versus small company type stuff. Not that Planet isn't growing, but like all these companies, like obviously you were Apple, not a small company, and you were able to. I know some people in the testing group there, but it's a very defined role versus a startup where it's like, well, just get this thing out the door and maybe launch it into space or whatever.
Yeah, do all the things yourself. Yeah, no, Apple has, everybody is doing the one thing they do best kind of thing, right?
Right.
Where we didn't have enough people on Planet, and that's why I ended up on the line, because we have to. the rocket's going to launch with or without you.
Right,
so
exactly.
You better test these things and get them on there.
So going back to what Jen said about the processor selection, so that sounds common, right? I mean, the decoupled hardware versus firmware decision. Obviously, that's not a great thing to do because not that you had the firmware pre-written anyways. So they're kind of just guessing on how much firmware is going in there. But so how did that end up playing out then? So you've got a fixed amount of memory on the processor. You've got these constraints that you had no input on, fine, whatever. But then you also have a time constraint of a delivery time. So how does that end up playing out in terms of? Yeah. Is it like are you allowed to? I mean, do the features actually get cut out?
Can you repeat your question again?
Sure. So the firmware is the. Actually, I don't know what the question is.
You were going down the road. It was like, hey, they didn't converse with you. So what happens when
shit sucks, don't it? Yeah, yeah. That's the synopsis. Shit sucks, don't it?
I feel like this is turning into a therapy session.
Processor.
I was just going to comment on it.
Podcast is for.
At least, and I think maybe I think you've had other guests that have come on here, and they remember there was a time period when the firmware engineer and the hardware engineer were the same person. There wasn't really a separate team And now...
And that happens with small teams as well, right? I mean, that's another thing that happens,
yes
right?
and no. It's not nearly as common as it once was. And, you know, at least when I talk with older hardware engineers, they remember writing firmware. That is not necessarily the converse.
Yeah, but a lot of times you look at that firmware and you want to cry.
Yes, that is also true. That'll bring us to a different, separate rant. But to go back to your question, and this also ties in with cycling through different job positions, is that it's hard for you to understand as a R&D engineer necessarily what customers' experience is going to be unless you actually put yourself in that position, or how to understand or how to design for manufacturability unless you're put in that position, unless you have to basically dog food your poop effectively.
Well, that's why I like this rotation thing. Is like, if you've been in the manufacturing test area, next time you're designing a product, you're going to put in all these features. It's what they call design for testing or testability or whatever. And I'm sure it's the same for your customers, right? And if you're using the product, you're going to kind of know what you want it to do in the first place.
Right. You're at least going to weep when you can't find the USB port, and you're going to be like, oh, I should tell them where the USB port is, or whatever it is, right? Some kind of empathy in design.
Yeah, I think it's kind of bordering along
someone did
that.
Talk on that.
Yeah, wasn't that covered by another podcast?
The test engineer, for the customer, or whoever. Sure, yeah. Who was it?
Yeah.
Embedded?
Yeah.
Someone else?
I think it was Chris Veck.
Yeah, I think it was.
It was
cool.
Empathy-driven design or something.
And I think he came back twice, didn't he?
Yeah.
Oh, he's a regular.
Yeah. Now he is, yeah.
Okay, so where are we going with all this stuff?
Okay.
It's your show. I don't know.
So I think you were trying to get me to throw hardware engineers under the bus, and
no, I mean, not trying to get you
I
to throw
remember
them under the bus.
You were talking about how like, hey, something's already been predestined, pre-chosen for you, and now you got to figure out like how you're going to make it work, and then there's this deadline that's looming over you, and it's a hard deadline. Well, the first thing I want to comment upon is that it's not a hard deadline. I would say for a lot of products out there really isn't a hard deadline.
They'll tell you it is. The product managers are going to be like, no, it has to be done by this date, or else.
Or else what?
And it never gets done. But,
well,
they just say it, It's like, no, we have to do this. We have to do this.
You've had really nice product managers. I remember my first product manager would just regularly threaten my job if I didn't get something done by tonight.
Oh, really?
That's another topic. I feel like we're getting down a therapeutic route. But anyway, so a lot of times what ends up happening is, at least on the last few projects I've been on, it wasn't the firmware that was late. It was the mobile app that was late. And they were the ones that were struggling to get things done.
Yeah.
So it's just kind of like you just pass.
I'm not trying to like throw anyone under a bus. I'm just trying to get to how. So the baseline question was how is consumer different, right? And so we've kind of talked about the volume stuff. Obviously that plays out. I've been asking about the firmware stuff because I think that would be different. Obviously, I don't have as much firmware experience in general. So, but yeah, just kind of, I guess the baseline question is how is consumer different?
Well, one thing for consumer that you might do that you might not, but one thing you might do with super high volumes that you might not do for a few hundred devices is you might have to get the parts pre-programmed, right? So you have to have your firmware ready ahead of time because it might be too small to have a programming header on there, or at least put a bootloader on it, right? That's something that with the bigger equipment, you can have your connector, that kind of stuff, and then program it right before it goes out. Whereas a lot of the high volume stuff, you just want the chips pre-programmed or programmed at the factory before it goes out.
So I can put this in perspective of all our favorite products, which we'll just put under the general header of Internet of Poop. And this day and age, the product never stops developing. It is always being updated. It's always being improved. So instead of thinking that you have to meet a deadline with all the features ready to go, you have to think about your firmware getting to a certain minimal viable product. And I think you guys talked at some point about
buzzword
lean startups and Steve Blank.
We've had Eric on the show, yeah.
And I've met. I've met Steve Blank and and that whole group of people. But today, like more and more organizations, whether they're hardware, mobile, wherever, they're running less waterfall and more iterative. And the way that IoT is set up, this works really well. So you just need to make sure that my gold master, which gets flashed into a product 3 to 4 months ahead of when we actually have the product land in someone's hands, can boot up, connect to the backend server somehow, and get updated with all the newest, latest, and greatest features that day 0. And make sure that is solid.
Right.
That's all I have to do.
And just like don't brick itself, right?
Yes.
That's the main thing.
Yes.
Yeah, you need a solid bootloader. That's if you screw
I
that
need a
one
solid
up.
bootloader, and depending on what happens, I need a solid app.
Oh, okay. Because sometimes it gets delivered through the Wi-Fi app to the app, and then app through Bluetooth to the device or something like that.
But I was talking about the app on the firmware itself. But yeah, the mobile app, I guess. But the mobile app doesn't need to be ready until literally the hour before launch. And I've worked for companies where it was done literally the hour before launch. Somehow made it up on the Google Play Store, somehow made it up on the iTunes Store, just literally in time. And right after that, we all got drunk and passed out.
Support request be damned. Yeah. Yeah, no, that is interesting how that changes the dynamic of the development cycle then because of those consistent updates.
I don't like it. It makes us lazy.
Really? Okay.
Well, because now you don't have your product doesn't have to be finished, right? Like John said, you need your minimum features. You might be have promised all these other things, and then you ship your product, but then. Okay, you have the idea, I'm going to implement all these other features, but they always start pulling resources, or they tell you to start working on the next thing, and people start half-assing things, and it just...
Right, and then I guess if you're not getting enough of the baseline features in there, then it's like this self-fulfilling prophecy of like, oh, well, we're pushing this thing to market, it's not completely done, and then, people don't seem to like it as much because they're, it's not.
It's more about people getting lazy about testing and making sure everything works, because when you can just send another update and fix it, why spend all this time testing it to make sure it works in the first place? That's what you should do, but if you don't have to, it's like, if there's a bug, we'll fix it later. It's a poor experience.
Okay, well, think about it this way. If the first thing I do when I start on a project is I make sure I have the capability of OTAing my device, then...
Yeah.
What I've enabled is I can send product out to a lot of different people internally and have a very limited alpha test. And then they get all the updates as we push them out. And I can get feedback, consistent feedback. And that's what we did. That's the first thing I did when I worked at BIA was make sure that we could do OTA. Because what was happening before was we'd have all these alpha testers and they would just physically send back the device to us. We'd put a new image on it and we'd send it back out to them. And that's really time consuming.
I think that's great. It's just when the customer is the one that's having to update constantly, right? When it's internally in testing, that's the best way to do it. But when you can update everyone's devices after they've bought them, and it's easy, people start getting lazy. That's the only thing I'm saying.
Right.
It's not that.
Also, I should cut in here. The OTA means over the air, right?
Yeah.
Over the air update. That's for a wireless device. Yeah.
Right. Just
just like on your phone.
Got to watch out for those.
Yeah, because if you look in like the Google Play Store, and I'm assuming iTunes, like any other release notes, it never says, "Hey, new and improved features." Most of the time, it just says with bug fixes.
Yep.
Right.
Oh, there's a good one. Someone said, "Fixed a few bugs and introduced a bunch more." Just being honest.
The honesty app.
Nice. So how does this end up playing together then with the hardware? Because obviously you both have your hands on hardware as well. I mean, and most firmware engineers do have that hardware, the need to be near it anyways. So how does that end up playing out? Especially like you're talking about these things that can't obviously hardware cannot be updated in the field. There's no OTA for hardware. Thank God. So how does that end up playing out in terms of consumer versus industrial versus delivery time, stuff like that?
I think for all of them, one of the things that also happen is the hardware engineers also get lazy because we can fix it in firmware. And that's just I don't like that, where we don't have to test it as much. We'll do a patch in firmware and hopefully work around it.
I guess.
But this is...
I could tell you how I've dealt with it on other projects. And it's primarily that your P0, maybe you have a bunch of different processors or some different architectures that you're trying to work through with different concepts. And you just kind of put them on this Franken board together just to see whether you can answer all the different questions that you have about what the product can and cannot do. And from there, you just basically trim out all the excess or what, based on whatever the feedback is from your testing and go forward. On the other side of it, you have your marketing and product management teams who should be working to narrow down like a bunch of different things. Like, hey, do we want 5 LEDs? Is 3 okay? Do we need an accelerometer? Do we need like a rubber ducky on it? Do people care? Who knows? And they should at least be willing to go, hey, if we just have these things, will we be able to, if we want to add this on later, will we be able to do this with the hardware as it stands now? And that's usually when some have. It's kind of a top-down, bottom-up approach where you kind of meet in the middle and go, okay, this will get us to X amount of value later on if we decide to go down that value. So as long as you have enough features on the hardware that the software can craft into something interesting and compelling, then that's usually enough that the marketing team can then go, okay, we're going to start with this first round of features, and then we'll just keep adding and brainstorming more and more and more as they're going through, leading up to launch. And then those that don't quite make it, but they still want, they'll just put into sustaining releases. And that's mostly what marketing has been trying to do. And what's interesting is that you want your app to be really cool. You want your IoT device to be really cool out of the box. But then in order to keep people using your watch or your, IoT rubber ducky or whatever, you need to keep putting in compelling new features every few months to keep them using it. And so that's a lot of the marketing strategy that they've been using.
Oh, interesting. Like a magical, like kind of a magical feeling to it. Like, oh, what can this thing do today? Is that kind of the idea?
Yeah, it's the whole idea is you gotta make it sticky. So they're just gonna give you just enough the first time to like make you happy, and then it'll wear off, and then they'll come out with a next release. And it'll give you something new that's supposed to, renew that sticky factor. Sticky being not physically sticky, but want to keep touching
Pokemon.
it. Yeah.
Dopamine-driven development.
So I think that's one of the parts that we don't think about on the hardware side so much is marketing. Like why isn't this feature in here now? It's ready to go. It's because they're trying to hold off to make sure that the product's still compelling. If you kind of drop all your load all at once at the beginning, it wears off fast. You want to keep some mystery.
Got it. So what about dealing with the actual volume piece? So you've mentioned the OTA stuff, and that I'm sure plays into this as well. But, some of these things that you've discussed are going out into the world in literally millions of volume. So how does that play out with, how that impacts your work? But then also do you have access to, are you programming parts that are not commercially available to someone like, some schlub like me? Is it like even custom silicon that's so leading edge that you then have to end up troubleshooting it and stuff like that?
I mean, in the big companies, you might not get, you will get some custom silicon, but usually it's just the cutting edge silicon, so it's not yet available, but it will be.
Yep, like early release kind of stuff.
Yeah, early release, especially for the big companies, or even once you say big numbers, they give you the parts early. And you're dealing with incomplete documentation. The errata's not quite there. There might be silicon bugs. So it's a little bit more of a challenge to get stuff up and running. But that's kind of the price you pay for
I've definitely been on both sides of the table for this part. Both being like, hey, here's some new silicon to use. And you're like, hey, how do I, what's wrong with this thing? And I've definitely been on the other side where I'm the salesperson or the FAE involved that had to break the news. Like, hey, so...
We found something.
It's going to be a 6-month lag.
We found a silicon lump.
There's peanut butter all over the silicon.
Yeah.
Sometimes the errata was the customer. A customer would find this bug and then come back to us, and we're like,
yep,
better document this. I guess
that's really real. You found it.
Yeah,
you found the golden bug.
You win the prize.
Working silicon eventually.
Yes, well, it's usually documented, not
got it.
silicon.
Yep. Don't use that spy bus. Use this spy bus.
Yeah, or turn off the spy bus and turn it back on whenever it hangs.
You tried turning it on and off again?
I currently use parts like
there's
that.
something in the ST Micro recently that I like about a year ago that had that problem. It would just suddenly just like give up the ghost, and you're like, oh yeah, just reboot it and you'll be fine. I'm like, what the hell?
Oops.
So when you're dealing with volume, you start dealing with those a lot more. And then also you start, as far as testing, when you test locally, you only have maybe hundreds of units, thousands at most. Once you go into the field, you have millions. If it's a problem that happens 1 in a million, if you have 100 million, this problem is going to start popping up. So as far as firmware, getting crash logs back is super helpful, but very rarely
possible,
available. But also just with the hardware and testing, just your tolerances on your things, you start seeing weird stuff that happens once in a while, and those things are hard to track down.
That's just all money. So half the time when you're evaluating these types of risks, you're looking at the likelihood versus the cost, and then anytime customer service is involved, it's super costly.
Oh yeah. Okay. Yep.
Yeah. No. But you have capacitor cracking that's causing some current leaks, or you're having just the microcontroller doing weird stuff. I mean, I'm trying to think of specific examples without
giving it all away.
Without giving stuff away.
What was going on in Apple that capacitors were cracking?
I never said those.
Actually, don't answer that.
Yeah.
So what about other? So that's interesting. From like you're saying, like the testing stuff. Obviously, there's just a lot of units out there. But what about other? Dealing with high volume kind of things. Of like, does that change deployment then? So from a firmware perspective, from a hardware perspective, do you get called when you have lot differences, and so like you have I guess that's kind of the tolerances things you're talking about. But
it's also if there's analog components and you have to do calibration, it's easy to do with a few units. But if you want to scale that, it becomes an issue. Also, just firmware updates, right? Firmware update for 1,000 devices is different from 1 million devices. If you screw it up, you can't just give everyone a bad firmware update. So you have to do staging, right? You have to give like 0.1% of the units, start seeding the new firmware image. Wait, okay, they didn't break. Okay, give it to 1%, 10%. So you have to be a lot more careful with your updates.
And this is specifically using OTA type over-the-air updates and stuff?
Yeah, so this is remote firmware updates. You have to be really careful. And then there's a whole security aspect too, which is just a whole other podcast. But you don't want someone else to do the firmware update for you.
Oh, right. Yeah, no, that's a good point. That's a really good point. I mean,
if it's connected.
So, you're talking about like, hey, we get some early access to silicon or we get this. But for the most part, a lot of consumer is not very forward thinking, is not very R&D centric at all. It's just repackaging stuff that they're getting from another vendor. And it's really the vendors that are absorbing all that R&D cost for you.
Like app notes and stuff like that, yeah.
Yeah. If you look at a lot of like consumer routers and stuff, it's just the networking chips reference circuit repackaged. And that also happens with software, which is an issue because people just take the example code, put it in the web server, and except that if you look at the example code, it has all these warnings that say, do not use in production. This does not have security kind of enabled because it makes it more complicated. So it's an example. They want to sell you this device, so it'll make it easier to test. But if you want to do it securely, you got to go through a lot more hoops. But people just say, oh, it works. Copy and paste the vendor code. It works. And now you have tons and tons of insecure devices out there.
It's even worse than that. Like, maybe you've worked with some vendors that had competent software people that would tell you, hey, warning, you need to do some other stuff. A lot of the stuff that I've gotten from vendors has been, is completely unstable and doesn't work and has its own set of bugs that you need to figure out and work through. And quite frankly, a lot of these schedules for the products are so tight that you may never get to them. You may never even find them before they go out into the field.
And then you turn it off.
I think that's a lot of the issues that I was going to say. There's a certain mobile chip manufacturer that has a lot of issues, but they've left the mobile game. I think you guys could probably figure that one out. They don't understand things like shared memory coherency.
Well, I guess they left the game, so that's good. No, that's an interesting picture of the industry though too. Of like, it's just the. I mean, so that is kind of the image I had of just the the time constraints, stuff like that. I think a lot of people are using reference designs, application notes, things like that in their designs. But what it comes back to is it verified? Is it tested? And then how much impact can it have? Because like you're saying, there could be millions of units out in the world.
Well, you say verified and tested. If it works on my desk, it might not work at a different temperature, different humidity, different battery levels.
Mm-hmm.
It's,
right.
Making
different fog conditions.
Making volume stuff is hard, especially when it's consumer electronics. For industrial equipment, you have a pretty good idea how they're going to use it, but consumers are notoriously good at using things for all sorts of things you never imagined. Right. So
right, yeah, none of my industrial products have ever been dropped in the toilet. So, and then they get mad at me, right?
Because why would you not make it waterproof? I mean, it's clearly your fault.
Yeah,
why
of course.
You do that?
Right, of course.
I didn't know that I could use the set-top box to open beer, but
wait,
I can.
You're saying I can't go heli skiing with this? What?
Yeah, that is a wide range. So well, I mean, we're talking about a lot of products are in the field, not a lot of timelines, but tell me about how does this stuff get handed off then? So DVT, PVT, all that stuff, right? So going to like from R&D engineering or just design engineering to a manufacturing facility or a manufacturing setup. What do you have to do in order to get that?
I mean, I was fortunate enough not to have to do that in most cases, but from what I've observed, I mean, usually, again, you start building small and start growing, right? So the first builds is going to be the design engineers with the CM, you get your boards, do they work, that kind of stuff. Once you start scaling, you need to get more people involved because you don't have enough, like the designers are just a handful. You can't have them in China 24/7 just making sure everything gets built. They do get sent, to the factory to make sure it goes, but then you start training other people to, understand the product and be able to respond to any problems that happen. And until you start ramping up, and now you're building thousands, now you're building 100,000. And it's it's all in stages, I guess. And eventually the design team is, you step back, they might start working the next thing. Now product gets shipped, you start getting field failures, and then those usually go back to the design folks, or you'll have a team kind of to triage that for common issues, but then the really tricky ones go back to design folks.
It depends on if you're using a contract manufacturer and what exactly they're handling for you. So you may be starting with your request for proposals from them, and you may have them just handle all of the manufacturing, including deciding what the test plan is, and you may have a hand in deciding or signing off on the acceptance criteria. Or they may also be doing the BSP for you for that particular chipset. They may be doing some of the design work for you. These days,
board support package.
Oh, yeah, board support package, BSP. They may be doing a lot of stuff for you as a CM, but it also depends on your volumes, what they if they already kind of have a product in their in-house that's already kind of fits the bill for what you want to do. So it's great if you are just a snazzy biz dev guy who doesn't have any engineers and you just want them to go off and build it for you. They can handle everything for you. If you have engineers and you want to do something that doesn't quite fit the bill for what they already have, then it falls a lot more in line with what you're talking about, Alvaro.
Isn't that what Dave's doing for his new meter? Just having people build it?
In Korea, they're an existing DMM manufacturer that are doing custom design for him that he did. So, yep.
Yeah, so I mean, there's you can do everything from hands off to all hands on deck.
Got it. And so there's no rhyme or reason across products you guys have worked on.
I think when you're big enough, you have all the resources and expertise to do it yourself. But when you're starting out, it's better. I think it's better to let the experts do it, kind of thing, right? Some people try to do it themselves. I mean, you've had I remember Saliate, right? They brought in manufacturing in-house, but it was a bit too much initially, and then they had to go back to CM. So it's really depends on the the product and what's required.
Has it been mostly China for the work? I mean, that's, I guess, another common thing with consumer is thinking, well, I always get frustrated when when you listen to like startup talks about hardware stuff, and they're like, well, of course you're going to go to China. And it's like, well, no, not necessarily. But if you're a consumer, then yeah, you probably are going to, right?
So half of mine hasn't been because like medical devices, usually you're close by. Satellites we did in the basement
in
San Francisco. Well, not in the basement, on the first floor in San Francisco. You should have seen it.
Wow.
Yep.
And
you can hear people's footsteps above you and like dust falls.
What kind of rickety halt and catch fire place were you working at?
I was just Planet Office, but eventually, they installed a clean room and everything. But right after I started, we had kind of pieces of plastic on the ceiling, so that the dust from people walking above wouldn't, get the satellites started.
Yeah.
Right. Well, and I guess satellites are ITAR controlled anyways, right? So that's that's a different thing. What about you, Jen?
So when I started doing manufacturing in the mumble 90s, it was actually up in Fremont, California. And there still are lots of manufacturing houses in Fremont, California. I even worked for one of them very briefly. So all those little, when you're up in SF, they have those little dots that can tell whether a parking space is open or not. They used to manufacture all of those. And I think that manufacturing house is still around. But during that time period, consumer electronics were enormous, physically enormous. But with the miniaturization, the requirement is, the skill required hasn't really caught up with the places here. So they can handle small volumes out here. They can't handle extraordinarily large volumes. You could go to Mexico. I think Ensenada is like one big manufacturing hub.
Yeah, they used to be pretty big.
Or you can go to China. The other place that you need to evaluate, or not place, but the other thing that you need to evaluate is what are you trying to achieve? Different manufacturing houses have different capabilities. And, obviously you have Flex and Foxconn as being the most visible ones worldwide, but they each have their own specialties. And it's not always obvious to most people when they're trying to find somebody, especially if it's the first time they're manufacturing something, that how to navigate and find the right CM for what they're trying to do. For startups in particular, there's a number of smaller manufacturing houses that will kind of give you an internship, I don't know, like a prize, and they'll invest in what they think are promising startups, and they will give you kind of free work. They will work on your project for X number of iterations to kind of, help and invest, but they're also kind of looking at from their angle, like, hey, if this takes off, we can, really make a lot of money here.
There's also the volume factor, right? In China, they make the components for the thing you're building right next to the thing you're building, or nearby. So if you have to scale and you have to build, a few million more this week, you couldn't do that in the U.S. You can't just go to DigiKey and overnight, 10 million whatever components. But if you're near the factory of those, you could just drive down the road and get them, kind of thing, or they'll ramp it up. And that's one case, right?
I would say, generally speaking, that's true. I think you've had like Bunny and some other people talk about the nuance there, which is, yes, they can have quick access to other people. That doesn't mean that those other people are bringing quality. It also may mean that there's some additional cost to get it there in a certain time. So just getting something from Hong Kong back into China is its own particular pain.
Right. Well, and you were both talking about firmware delivery to different devices and stuff like that. And if you start varying, product, from one run to the next, it's gonna, you're gonna have other issues that you have to track and stuff like that.
Yeah, there's very clear incremental changes you're trying to do build to build. Early on, it's really focusing on being able to validate the design, the engineering design, and then it's moves more towards validating the process of building the product itself. And then sometimes, actually more often than not, I'm noticing it kind of gets all smushed together. So you're kind of doing two things at once, whether you should be or not.
I wanted to ask one more thing about kind of the volume manufacturing stuff, and then I'd like to touch on a little bit more reverse engineering. But so I've seen some of Alvaro's stuff out in the wild. I own one of the Amazon Fire boxes that Jen mentioned. Obviously, you've both seen successes and failures. So I guess that's another thing that no one has ever talked about the product that I've worked on in the past. You know what I mean? Maybe Dave has talked about test equipment that I've helped on, but that doesn't really count. So what is that like then? I mean,
it's pretty. I mean, I worked on very, very early prototypes for some of the Apple stuff that I've seen out there, and it's cool now that it exists. I can tell people like, "Ooh, I worked on that," and it's I don't know. It feels better. Working on stuff in secret is that's rough because well, for me, I'm a total nerd. I love telling people about the stuff I make because I love making it, right? So once I'm able to say, hey, I worked on that, it really, I don't want to say validates, but it encouraged me to do more.
And Jen, what about you? Because you have that comparison specifically for the Amazon phone, which didn't really hit the mark, and then the Amazon Fire, which I think, or the Fire TV stuff, I think that's one of my favorite devices.
Actually, I really like the Fire TV. So I think the thing is, like, when I was working on more industrial or networking equipment or call center equipment, it was difficult for people to understand what exactly I do. I'm like, I make the hardware go, I make the lights blink, and it still doesn't sound very impressive at all.
Doesn't register with them.
It doesn't register. It doesn't resonate with them at all. But being able to go like, hey, I work, walk into someone's house and go, oh yeah, I worked on that. Every time the picture scales to the right resolution, that's me. Or the fact that you can talk into your microphone on the Fire TV remote, and it records your voice. I can talk about that, and that's really cool. That people just can really understand, like, oh, you did that.
Mm-hmm. Yeah, like that
it just makes me seem like, oh, I'm not just some dorky engineer. I mean, I know I'm a dorky engineer, but it means that people kind of can understand what I'm doing.
Right.
But it's a lot of work to get people to see it, though. That's the problem.
Yep.
Right. Yeah, it's a different set of challenges, stuff like that.
Explaining firmware to people is hard.
Well, I mean, I tell people that I work on electronics. I'm not like, well, if you look at resistor 1 here, it's not like
I did that.
Well, I tell people I write firmware.
Yeah.
And they're like, what's firmware? It's like, oh, it's like software for microcontrollers. What's a microcontroller?
No, I would never. Why would you ever dive that deep? Like, just treat everyone like you're talking to your grandmother. No way, man. They ask because they're confused, not because they care. No offense. I mean, I care. But like,
some people care, Chris.
Some people care, but they're the people that already know what you do. You know what I mean? Like,
I don't know. They might care, but they don't know yet.
If you go to a cocktail party, and they're like, "What's a microcontroller?" If you went to a cocktail party and someone asks, "What's a microcontroller?" It'd just be nice.
Chris, you're going to the wrong cocktail parties. I don't know why you didn't move out here. Yeah. I don't know why you stayed in Chicago.
I actually had to give this speech yesterday.
Well, that's actually okay. So I did think of another question too. So. Interestingly, so Jen, you mentioned a lot of companies. Alvaro mentioned a couple companies as well. So then what's the job market like in consumer? I mean, obviously, you do have to live in the Bay Area. Well, that helps if you want to have a lot of opportunities.
You don't have to.
It helps.
Yeah. But it certainly helps. Yeah. I mean, there's lots of jobs here right now.
So the hopability, that word I just made up, the hopability between jobs, I mean, is it like the software craziness where people are... recruiters are calling and ringing your phone off the hook? What's that like?
Most of the firmware engineers I know are happy, or they're working somewhere, so they're not actively looking. And the recruiters, at least where I have worked, are always desperate for firmware engineers. So I don't think there's enough.
Like, I'm interviewing firmware engineers like crazy, and I'll be honest with you, it's hard to find a competent. I don't mean like incredible. I mean competent.
The competent ones are working
firmware
somewhere.
Engineer, and when we can bring somebody in, it's disappointing. It's super disappointing. So that said,
I think part of that is just
if you want to move jobs in Silicon Valley as a firmware engineer, you have a really good opportunity to like just find any number of different jobs because people are so desperate that you don't have to be an incredible algorithm developer. You don't have to be able to do DSP work. You just need to be able to write string copy.
Well, and a lot of times, you go through not the software engineer interview, but more of a hardware engineer interview, which and Silicon Valley tends to be a little bit more forgiving.
Yes.
They're pretty vicious with the software engineering interviews here.
Oh, you just mean in comparison. I thought you meant like compared to elsewhere in the world. So you're saying...
No, just in Silicon Valley, software is even more competitive. Or like there's tons of candidates, so they really have to filter them out to get the good ones.
Got it.
So they really pull no punches in those interviews.
Right. And so it's more like, oh, you know what components are. You've programmed a microcontroller. Welcome to the table, at least, right?
Yeah, we'll talk to you.
Yeah. Okay. That's good. I mean, that's good for people to know.
Are you saying that I should just become a hardware engineer?
I'm technically a hardware engineer in my current position, but I write firmware. So I started doing PCBs now.
That's very interesting.
I'm just saying there's other ways.
And I've also done PCBs for PC 104
Nice.
boards.
What software were you using back then?
I was going to say, it probably wasn't KiCad, huh? It was PC 104 era was not
no, it was not KiCad.
Congruent with KiCad, yeah.
It was standard OrCAD.
No, they're still using that.
Yeah.
Ask me about mouse controls
gestures?
or mouse gestures.
Oh, man, I've heard bad things.
Ask me about mouse gestures in Mentor Graphics.
Wait, is that the one where you do like a Z? Is that like a Z to zoom? Is that the one?
No, you don't do that. You just like do a slash down,
okay.
and you zoom in and you go the opposite way, slash up, and then you zoom
While
back
you're
out.
pressing a key, or?
I don't think the button. While you press the mouse button.
Well, that's not bad.
And then undo is like you do a little counterclockwise circle.
Shake your computer.
I feel like I'm interviewing for a job right now, and all I got for you is I don't know anything about resistors. I knew mouse gestures.
Well, let's interview based on y'all's interviewing. So on the unnamed reverse engineering podcast, what are the people you've talked to so far? Who's coming up? And then what have you learned about reverse engineering so far?
I mean, so we've talked, 2 episodes has just been us talking to each other, which I wouldn't recommend. And then there's
you wouldn't recommend talking to one another, or you wouldn't recommend listening to those shows?
The alternate
I'm gonna leave
name
that
for
one out
those
to
episodes is
interpretation.
Gigglecast, I think.
The first one was for sure.
Yeah.
But we talked to Dmitry Greenberg, which you might know of as the guy who ran Linux on an AVR microcontroller.
Good Lord. Okay.
Yeah, that guy. And
He's an awesome reverse
great
engineer.
Yeah, really fun. I learned a lot just listening to him. And then Scanlime, Micah Elizabeth Scott. You've probably seen some of her stuff online.
Yeah.
That was a ton of fun, and again, especially because she was kind of the reason Jen and I started, talking about the podcast. We saw her videos and said, "Hey, we should do something like that." And now we're using the podcast just like you guys and everyone else to talk to cool people and learn more about it.
Yeah.
Because I'm not an expert in reverse engineering, but I find it incredibly interesting and useful. So if we're able to use this as a way of getting people to tell us all sorts of cool stuff, their projects and that kind of stuff, I'll take it.
Yeah. So what about are there projects that you both have on the horizon then that you're hoping to reverse engineer? I mean, I know Micah does a bunch of what was it, like opcode stuff on the WinchBot, right? It was like checking out the
she had the controller on the pan tilt or the gimbal controller, I guess. She had to reverse engineer the firmware for that so she could make it do whatever she wanted.
So what are you both doing? I mean, are you using this in your everyday jobs? Or are you guys trying to...
I have used it in my jobs before, where we were trying to integrate some a device with a battery, and when you put a generic battery, it wouldn't work. So the fancy batteries had a like a little serial protocol that would authenticate, and so would do a bunch of data captures and try to emulate it. Or another time, we had a battery tester that was just some I don't know if it's generic, but some Chinese battery tester for 18650s for lithium batteries, and it would just discharge them and charge them, discharge them and charge them, and tell you the capacity of them. And this thing would spit out either some binary file or a horribly formatted Excel file, and I needed more than that. So I opened up their binary file on a hex editor, and I started looking for patterns, and then I eventually wrote a Python decoder for their binary files to be able to export it to whatever I needed to be able to kind of log log data and do stuff with it. So that was a fun little reverse engineering project for work. It's mostly just when you have tools you don't understand.
Just so I'm clear, you said the fancy battery you were using basically had some IP protection on it, so it was the K-cup of batteries.
It was something that the battery's fancy enough that it had some sort of protection, and we needed to power it constantly. This was just for a test project, and so if you just connect power to it, it's like, oh, I don't know what this battery is, and it still worked, but it would put up this display saying, oh, I don't know what this battery is. And we're trying to remotely operate something. It doesn't quite work when there's a dialogue waiting for you to click on it.
Right, yep.
So it was mostly an inconvenience thing. We ended up figuring another way around it. But
And Jen, what are you doing right now? Have you used this in the past? Or
So it turns out every year I have a birthday, and I came upon a birthday card that I had received, and it amused me greatly. And it basically, you open it up, and the lights come on, and then you blow out the lights, quote unquote, and then it plays happy birthday to you. So I want to reverse engineer that greeting card. So I don't know if anyone's seen on my Twitter feed, I've been asking about how to remove this darn epoxy. And I think I may have, yes, there have been offers of acids and videos traded.
John McMaster, who runs the reverse engineering meetup in Mountain View, he's the IC decapping king of the Bay Area. He has IC pictures, siliconprawn.com or .org is his website.
And X-rays and
Yeah. You want to stay away from wherever he's doing it.
We had Ken on a while ago, 2 shows ago as well. So he's big into that stuff.
Yeah, so we've been talking to him as well, because he does some fantastic reverse engineering, and he's given talks at the meetup, the local meetup.
Oh, cool. Okay. Wait, what is this meetup? It's a reverse engineering meetup in the Bay Area?
So it's called the Mountain View Reverse Engineering Meetup, and they meet once a month.
Okay.
And, like in the back of a barbecue joint.
In the Dickies barbecue shack.
It's sketchy, but it's great. No, but some great talks happen. They're not recorded, so people are a little more willing to say stuff, let's just say, that you're like, whoa, what? and some really cool stuff they talk about. So it's a cool resource for people in the Bay Area.
Well, so it sounds like some of so if I was going to list out some of these things, like you're talking about the firmware dumps, that seems like that's a big skill that you need to have, being able to read the hex files, stuff like that. Knowing like what Joe Grand does, like JTagulator, finding the JTag ports and being able to reprogram things, that's a big piece. Are there other skills in there that kind of cross over into the hacking world, or what else is in there?
I mean, a lot of the skills used in reverse engineering are also very useful for debugging your own product, right? Because you're trying to see how it works. You're probing around, you're looking just how stuff is working. And I might be working my own product and stuff's failing, but I might look at it and be like, oh, I remember this time I was doing something like that, and go do that. Also, you get to learn from other engineers' work. You might be opening a really fancy piece of equipment that someone made a long time ago and clearly spend a lot of time designing it, and you get to look at it and kind of take it all in and say, whoa, I never thought of doing stuff this way. Or this is really elegant design, or whoa, this is horrible. How does it even work?
Right.
So it's kind of a way to learn as well. Yeah, a physical bug.
Why?
I don't know if there's a physical bug. How old is the electronics that you're opening?
Oh no, I have gotten some old stuff, but that was
I mean, this sounds like that's also what Dave does with teardowns, stuff like that. People that are doing teardowns, understanding how it all gets put together.
It's just the teardowns are mostly hardware. Ken's reverse engineering hardware stuff. I'll focus on the firmware. So the Proto-X, the quadcopters I did a while back, that was just for fun. Like I really had no need to reverse engineer this $30 quadcopter, but I saw Scalelime's video, and I wanted to do something of my own in that similar fashion, just to teach myself, to prove that I could do it. And I just reverse engineer the radio protocol. So instead of trying to dump the firmware in this case, I tapped the communications between the microcontroller and the radio chip and just looked at that, and then connected my own microcontroller to the radio chip and was able to do it that way. And that just taught me about how this radio works, how the controller works and all that stuff. So it was fun.
Cool. That's great.
And no one died.
Right. Yes.
This also kind of sounds like some of these skills are like the stuff that I was blown away with. If people didn't listen to the interview we did with Zach from Zachtronics, like the Shenzhen IO game, like that seems like that's a lot. Like his games are also a lot of reverse engineering and
like challenges.
Yeah, and I was just incredulous that whole show. I don't understand why he made those. I still don't understand it, but it sounds like that's a good practice. I don't know if either of you have played those.
People like puzzles.
Yeah.
I mean, I have a lot of friends who drop a puzzle in front of them, and it's they call it nerd sniping, right? They have to solve it. They can't not know it, and that's what a lot of the great reverse engineers do. I mean, we interviewed Dimitri.
They just keep going,
and the only reason
they just keep going.
Well, the only reason he reverse engineered the PSOC was because the data sheet said that the user could not read a part of memory. And that's just challenge accepted for him. And just because they told him he couldn't do it, he just wanted to prove that he could. That's as much as little as it takes sometimes.
And that's why he also did the Dreamcast VRMs. Sorry, VMUs.
Yeah, because can be done. So like, oh really?
Right. Hold my beer.
Hold my beer.
I didn't even seem like a beer drinker, but yeah, sure.
It's a turn of phrase.
Yeah.
Well, that's great. So I'm looking forward to listening to more of these shows. Where can people find this podcast?
Unnamedre.com.
Yes.
I think. I don't know.
Yes, not HTTPS.
Yeah, so it's UNNAMEDRE.com.
Until we find a name.
And then you can also on your podcast app just search for Unnamed Reverse Engineering Podcast. We only have 4 episodes. Yeah, we should record some more.
Yeah.
I'm in the process of moving again, so
where can people find you both online?
I'm on my website's alvarop.com, ALVAROP.com, and on Twitter I'm just my first name and last name, Alvaro Prieto, at Alvaro Prieto.
I'm Rebelbot Jen on Twitter, and you can find me at rebelbot.com, and that's pretty much all the only places I think you can find me, unless you find me on the street.
Okay.
But then they won't know.
Right, exactly.
You.
Who is this mysterious person that's ranting about firmware to me?
Chris doesn't have his Google Glass anymore.
Oh yeah.
They give me $1 and tell me go away.
I remember the first time I met. I don't know if it's the first time I met Jen, but you had a little 3D printed camera cover for Chris.
That's right. Yeah.
At the 10D.
Yes,
meetup.
I did.
I still have that.
I was that
still
person.
With the Google Glass. Yep. It's sitting next to me, underused.
Oh, they didn't take it away?
Didn't take what away?
The Google Glass?
Why would they take it away?
They have to find you to take it away, man.
I don't know.
So I guess what he's trying to tell you, Chris, is that someone was supposed to come in the dead of the night and like take it away from you.
I don't know.
Without you knowing.
I don't think so. If there's a buyback
give you
program,
an enterprise version.
I'm happy.
You're happy to sell it?
I'm happy to sell it. I'll take an enterprise version. I don't care. So.
Wait, you're not using it right now?
I know, exactly. I mostly just use it at home. It's just a casual, just my home automation thing.
To tell you what's next on your calendar.
Right. Well, thank you to you both for being on the show today. I'm looking forward to hearing more about reverse engineering, and I appreciate the hearing about commercial electronics in general. I thought it was really, really cool.
Thanks for having us.
Thank you.
Talk to you soon.
All right.
Thanks a lot.